Hello everyone, I am Ankit Kulkarni. My project topic is sentiment recognition in images using Emotion API and evaluating its results against other APIs. This project is done for the course EEE6512 Image Processing and Computer Vision. Emotion recognition is simply identifying human emotions displayed using facial expressions. This process is natural for us humans, but to make computers understand emotions, various methods and algorithms are required. Computers can now identify emotions displayed in images as well as videos using frames. The basic emotions vary according to different psychologists, but as emotions are universal, most of them are common. According to Robert Plutchik, there are 8 basic emotions: fear, anger, sadness, joy, disgust, trust, anticipation, and surprise. Now, what are the problems with emotion recognition? One of the problems is that every individual doesn't possess the same amount of proficiency in identifying emotions. The dataset used to train machine learning algorithms needs to be extensive, because if the data is comprehensive, the algorithms get smarter and can predict better. Subjects used for creating image dataset usually pose for the pictures, which can very well differ from the natural expressions. It is easier to predict emotions for faces which are front facing, which might not work well when the face in the image is rotated more than 20 degrees. Now, how exactly does computer understand emotions? There are numerous methods that can be used, such as support vector machine can be used as a classifier for sentiment recognition. Support vector machines are supervised learning models. SVM algorithms assign newly incoming test samples into categories after analyzing data for classification. The first step in identifying emotions would be to detect faces in the image. Classifiers like Haar feature-based cascades are used for this purpose. It is it is a technique where a cascade function is used to detect objects in images after it is trained from several negative and positive pictures. The emotions can then be identified using local binary patterns and coded face texture. Local binary pattern is a type of visual descriptor used in computer vision for classification. Emotion recognition has a lot of applications, and its scope can be broadened even further in the future. It can be used for marketing products appropriately based on the emotions users experience in presence of the product. Driver monitoring systems are in place today, which track the faces of drivers and the emotions and help to prevent driver from falling asleep. So it monitors the drivers continuously, and if the driver's eyes are shut for too long, or the emotions depict that the driver isn't aware, then it sounds an alarm which which helps the driver not to prevent driver from falling asleep. Counselors can track emotional states of the clients uh, using emotion recognition during their counseling. Online tutors, while educating students, can sense their moods and adjust their presentations and teaching style accordingly. So if a student is maybe bored, the teaching style can be adjusted and made more interesting. If the users of an ATM machine seem to be scared, there might be a possible robbery or some other scenario, and the ATM machines can be configured to not dispense the money in such cases. Mobile and web applications can be developed that track moods of the users and play music suitable to the mood. In this project, emotion recognition APIs are used to predict emotions in images. API is a set of routines, protocols, and tools which defines the way a software requests and receives service from another software. APIs used for the project are Microsoft's Emotion API, Sky Biometry Face Detection API, Sitecorp's Face API, and BetaFace API. So let's move to the code. So this is the Python code for the Microsoft Emotion API. So these are the libraries imported: CV and other libraries to display the results. So to call the Emotion API, the user needs to subscribe with Microsoft to get a key and the URL that you need to call. This is the process request function where the request sent to project Oxford is processed. Now here we check the response status code and take appropriate action. And this function is used to render the result on an image. So whatever the face, when it is detected, the rectangle obtained um, is drawn on the image along with the dominant facial expression, that is the current emotion here, uh, is displayed on the image. Now we can call the emotion API using two different methods. One can be using an image which is on a URL, or it can be done using an image which is on the computer memory. Here we'll go ahead and forward upload an image from the computer memory, which is the image. This is the image that we're going to upload. So I've already executed the code above, and I'll just go ahead and execute this. So it takes a couple of seconds to get the result. It it uh, it shows the face that is detected in the rectangle and the dominant emotion for the image, which has the highest value. The values for every emotion are normalized so that the total of the values is 1. So here in this image, happiness has 1 um, value, and others have almost negligible value. So it it strongly predicts that the person in the image is happy, which is correct. Now in the Sky Biometry API, we can directly upload the image from the memory and get the result. So this is the result obtained, which along with the emotion also gives gender, also predicts whether the person in the image is wearing glasses or not, whether the person is smiling, age estimation. So here it is predicted happy as the emotion. with confidence 63. So um, for emotions, for the emotions values in the from the APIs, we have we in this project we have a threshold of 50 or zero point 0.5 for emotion API, so that whenever a value, whenever an emotion has a value of more than 5 or 50 or 0 0.5, we consider that as the dominant emotion. So for the beta phase API, we use the same image to get the result. So the result obtained is smile with a confidence of 75%. It also gives out whether the person has mustache or not, and whether the person is male or female, its race, age, but we are concerned with emotions only for this project. So this is the SiteCorp web API. Even this API predicts a lot of things besides emotions. So it predicted that the person is female, the age of the person, and the dominant expression to be happiness, though it is not above 50. So we don't consider it as the dominant expression. So these are some of the results that I've obtained. So um, all of the APIs were able to predict accurately for this particular image. Now, for the context of the when the images are clicked, the background behind the image matters a lot in predicting images. So there's also a problem because in this image, the player has scored a goal um, in the ice hockey tournament finals, and this was a winning goal, and the player is definitely happy in this picture if you know the context, if you know the background story. But if you look at the image and you don't know anything about it, you'll probably think that the player is angry, uh, angry more than he's happy, of course. So the prediction obtained from the APIs is varies a lot in such images, and Microsoft API still got it pretty accurate, as it predicted that the player is angry in the picture. The other APIs did not do as well. This is the same image that was demonstrated earlier. So from the images tested, it is obvious that Microsoft's emotion API is way ahead of its competition. And um, if a mobile application or a web application is um, to be developed and emotion recognition has to be included in it, the best API currently available would be Microsoft's emotion API, as it beats every other API in terms of accuracy and ease of use as well. These are some of the references. Thank you so much for watching this video.